So this is obviously a radical equation. What is the idea here? What would be the first step? Walk me through. What would you do? Say it again.
I would say get rid of the radical. Get rid of the radical, square both sides.
Right. Don't write anything. Don't write anything. If I square, do not write anything. If I square this and then this, the right-hand side is 64. What happens here? And please think in terms of our agreement. You cannot tell me 2x squared and the square root squared because we signed an agreement last week. So what will you say? First term squared, 4x squared plus 2 times 2x times the square root plus the second term squared. Does this work? Did I get rid of the radical? No. So say it again. If I do, I'll be in even bigger trouble because I'll have 3 terms on one side and I will never be able to solve. Get the radical by itself. Very good. Because we have only one radical. There are equations in which there are 2 radicals present, which is a different story. But yes, indeed, we have to isolate the radical. I completely agree. Now, what do you think we're going to do? Yes, indeed. So please give me the left-hand side. Correct. We have an agreement. I don't want to have 2 terms coming back at me. I need 3 terms. And I'm ready when you are. And no, don't foil, please. That's why we signed an agreement. It cannot be because we square. That's fine.
4
yes?
X plus
squared
plus
minus, if one of them is minus, the middle term must be minus. Yes?
2
Yes? Times 2, which is 4,
4
times 8.
X
Plus,
the 8 squared is 64.
that's it. Excellent. First term squared. 2x squared is 2x in parentheses squared is 4x squared. Minus 2 times the first times the second. 2 times 2 is 4. 4 times 8 is 32. X plus the second term squared, which is 64. Excellent. Now what type of equation is this? Once I identify it correctly, I'll know what to do. Exactly. Now let's dig deep. What do we always do with a quadratic? I shouldn't say always because there are minor...
Simplifying factor.
Exactly. Set it equal to 0. So I'm going to move these 2 terms to the other side. So I have 4x squared minus 33x plus 63 equals 0. I subtract x from both sides, and I subtract 1 from both sides. Now this is a tough situation to factor because of the numbers. They're quite big. I'm back to the same procedure. 1 is not the leading coefficient. This is not a perfect square, so it's the same thing over again. I'm looking for 2 numbers whose product is and whose sum is. What is the sum? Yes, that never changes. What is the product? You don't have to multiply it. Just tell me what it is. This times this. 4 times 63. I recommend do not multiply those. I'd rather change them into prime factors. So this is 2 times 2. What is 63? It's 7 times 9, correct? But 9 is 3 and 3. So 3, 3, and 7. These are the prime factors. That's the key. Prime factors. Since the product is positive of these two numbers and the sum is negative, what symbol should those numbers have? The product positive, the sum negative. Very good. Both must be negative, no question. Good. So now let's try and use all these factors, all of them, and come up with two numbers only whose sum is negative 33. But I have to use all factors. So here's one option. 12 and 21. 12 and 21. And I got it. I'm done. Negative 12 and negative 21. Minus 12 minus 21 is negative 33. Yes, it doesn't always happen like that. I may have to say, okay, maybe I have to say 14 and 18. Maybe I have to say 28 and 9. But I have to use all factors. Yes?
Could you really point, even though it's factorable, use the quadratic formula?
Correct. We just didn't get to it yet.
Okay.
Yes, of course. Unless the problem is asking us to use factoring. But even if it's asking to use factoring, you can still, and you go back and factor.
Okay.
Yes. If you remember the quadratic formula, yes. Well, we're going to talk about it in chapter 2 or sooner. Okay, so then I have 4x squared minus 12x minus 21x plus 63 equals 0. We did not change the problem. We just replaced negative 33x by these two. I see 4 terms. And no, I will not go back and combine like terms. They will be going backwards. So what comes out from the first 2 terms? 4x, right? Yeah, that's it. And in parentheses?
X minus 3.
What do I have to have? Look, I write x minus 3 and I write the equal symbol and 0, because if I don't, if I omit the equal symbol and 0, then I will never solve. I will just change it into an expression. So what do I get? It must be there. No question, because we determined the only 2 numbers whose product is all this and whose sum is this. No one can find another. If a polynomial is factorable and I find the correct factored form, you cannot find another correct factored form. So negative 21. So now the common factor is good. And what is left in parentheses? 4x minus 21. And the options are? Now we have to write a big note here, which is crucial. Yes. Note. I didn't tell you, but we used the principle of powers. We raised both sides to a power. Every time we raise both sides to a power, we must check the solutions back in the original problem. So that's our note. When applying the principle of powers, it is mandatory to check all prospect solutions back in the original problem. It is a must. I cannot conclude whether these are the solutions before I go back and check. When I was taught these equations by actually my grandma, she did it differently. She said you have to state the restrictions first, even for the radical equation. And then I wouldn't have to worry about going back and checking. But we're not doing it it's that way anymore, so now we have to go back and check. So 2x plus the square root of x plus 1 equals 8. I'm going to check 3 first. I will replace x by 3. So 3 plus 1 is 4. The square root of 4 is 2. This is 6. 6 plus 2 is 4. So I will say to this, yes. But now I have to check 21 over 4. So 2 times 21 over 4 plus the square root of 21 over 4 plus 1. And let's see what we get. I will simplify because I'm simplifying factors. So in 21 over 2 plus, I have to find the least common denominator, which is 4. I need to multiply this by 4 because it's 1 over 1. 21 plus 4 is 25. 21 over 2 plus 5 over 2. But this is 26 over 2, which is 13. Since 13 does not equal 8, what do I conclude about 21 over 4? So the only solution of this equation is 3. This requires a lot of work. Okay, what else would you like to see? Quadratic in form. So let's look at equations. Quadratic in form. Any questions before we move on? Any questions before we continue? Any questions? Okay, quadratic in form. Perfect. So let's look at 99. X to 4/3 minus 5 times x to 2/3 and plus 6 equals 0. First of all, how did I pick this equation? By simply looking at it, I said to myself, oh, this is a quadratic in form type of equation. 2/3. Sorry. So x to 4/3 minus 5 times x to 2/3 plus 6. How did I come up with this? How did I say, okay, oh, I'm looking and I realize that it's quadratic in form? You will be able to do that very quickly as yourselves. So here's the answer. How did I know that this is quadratic in form? Because I realized that if I denote this quantity, well, give me a letter, not x.
T.
T, perfect. T is a perfect example. If I denote this by t, obviously it's clear that this must be and will be t squared. Indeed, absolutely. If I square this, I copy the base and multiply the exponents. 2 over 3 times the square will give 4 over 3. So by inspection, if you want, by simply looking at it, I said, oh, okay, 2/3 multiplied by 2 is 4/3. So if I square this quantity, I will get this quantity. So that's why I knew that this equation is quadratic in form. In other words, the equation now is t squared minus 5t plus 6 equals 0. And this is way more human, right? Much easier to even look at. This really hurts my eye, but this doesn't. And I know how to factor this because the leading coefficient is 1. How do I factor it?
T. Oh, that's T. Multiply T times 6. No, it's
There is no need for that long procedure because the leading coefficient is 1. So this is the product, this is the sum.
to negative 2, negative 3.
Equal symbol and 0. Good. So then I have two options for t. What are the options for t? But this is not the end. This is the result for our substitution. So this is the substitution. We substituted x to 2/3 with t. So this is our substitution. So we solve for t. But the original problem is in x, and I have to solve for x. So how do I continue? What does this equation say? What does it mean? I have to go back to my substitution. What is this equation? Very good. Equals?
2.
Very good. What will this equation be that I have to solve? The same thing. X to 2/3 equals 3. Very good. Perfect. What do I do now to both sides? These are basically now radical equations. Remember, this is the cube root of x squared equals 2. And this is the cube root of x squared equals 3. You can solve this or solve this. Same thing. So what will I have to do to both sides of these equations? What procedure do I apply? Very good. Either cube or raise both sides to 3/2. I prefer that. But it's take, cube and then take the square root. That's fine too. Let's do that. Since you mentioned, it's even better actually. You'll see in a moment why. So this is x squared equals 8, and then the same thing here to the 3rd power, and this is x squared equals 27. Perfect. What now? I cannot simplify. Yes, I would have to apply the square root. What do I get? And remember, these are quadratic equations. How many solutions will we get? 2 solutions. So plus or minus. Remember, this is 4 times 2. So this is 2 the square root of 2. And this is x equals plus or minus. And this is 9 times 3. So it's 3 the square root of 3. Any questions? Any questions?
Yeah. Can you walk me through the last step again?
It's quadratic. I have to obtain 2 solutions. So when I take square roots, I have to write plus or minus. So maybe this is easier to see. X squared equals 4 means x squared minus 4 equals 0, which is x plus 2, x minus 2. So that's why I get plus or minus 2. Or if I take the square root, I get this.
Okay, that's kind of where it was.
Yeah. Same reason. Any questions? Yes, I raised to a power, like power 3. When we raise to an odd power, the solutions will always work. Be very careful with that, but you still have to show, but I'll let you show that. Okay, next equation. So this was quadratic in form. Absolute value, polynomial, and models with absolute value. Remember how to study for this course. Redo the problems we do in class. Look at the examples in the book. Do odd number problems. Check the answer in the back all the time for each and every section so you don't fall behind. So we said absolute value. Okay, here is 105. The absolute value of 3x plus 5 equals 1. This is not a linear equation. Do not treat it as a linear equation. It's an absolute value equation. So here's how you think about this. The absolute value of what number or numbers is 1? How many numbers have the distance from 0? That's what this means. The distance from 0 1 or negative 1, which means this expression has two options. So 3x plus 5 can be 1, or 3x plus 5 can be negative 1 and nothing else. So the first one, I move 5 and divide by 3. What do I get?
Say that again, sorry.
It's a linear equation. I move 5 and divide by 3, so it's negative 4/3. And the next one, I move 5 and divide by 3. What do I get? Negative 6 divided by 3, negative 2. So these are the solutions. Okay, models and polynomial. Which one? Which one? Models. Okay, let's say,
One question.
yes, please.
Does it have like an inequality version of this?
That is for absolute value inequalities.
Yeah. Yeah.
Yes, it has two ones, outside and the inside.
Mhm.
Yes, correct. So let's say yes. So let's say 39. So a squared plus b squared equals c squared. Solve for b. Does this ring a bell? Some of the problems I chose from the recommended ones, so that will help you when you work on those problems. So it is the quadratic formula, the Pythagorean theorem, correct. So what do I do next?
Square root of both sides.
I cannot take the square root from a sum. Let me remind you. Okay, very good. It's a very good question. If you don't, even if you ask a question or if you make a mistake, it helps me refresh your memory on topics. So never be afraid to make a mistake. So the square root of a multiplied by b is the square root of a times the square root of b. The radical of a ratio is the ratio of radicals. But the square root of a plus b does not equal the square root of a plus the square root of b. Here's an example. 4 plus 9. This is the square root of 13. So the square root of 4 plus the square root of 9 equals 2 plus 3. It does not equal the square root of 13. So please remember these rules. The square root of a sum or difference does not equal the sum or the difference of radicals or square roots. So there must be something else I need to do here then. So when I solve a squared plus b squared equals c squared, and I solve it for b, what do I have to do first? Get b squared by itself. So I have to move this term here. B squared equals c squared minus a squared. Perfect. And now what should I do to both sides? Since this can represent a Pythagorean theorem or not, I will have to use, unless I'm told is the Pythagorean theorem, which means a, b, and c must be positive, right? Because they're distances. Otherwise, when I take the square root, I would have to consider that the equation has two solutions. If you want to consider it that model, then you will say a, b, and c are 0, so I will not put plus or minus. Otherwise, you have to write plus or minus the square root of c squared minus a squared, and you cannot further simplify this. The square root of a difference cannot be simplified. And the last type, polynomials. So let me look. Something that is not quadratic in form, and it's also a polynomial. If not, I will make one up. I can't find a specific example that is not quadratic in form as well. So I will make one up. So polynomial. Okay, So when we solve a linear equation, how many solutions we expect? When we solve a quadratic equation, we expect. When we solve a cubic equation, we expect. What degree does this polynomial have? Careful, think about it, and tell me the degree. Because when you say degree blah, then we have to come up with the same number of solutions, even if they repeat themselves. 5. X squared times x will be x to the 5th power. So this equation is polynomial. It has degree 5, and it has to have 5 solutions. Good. So I see 2 of them quickly. Which solutions? 1 and -2. And I also see quickly the other 3 solutions it happens that they are the same. And you will see in chapter 3 what this means. Very important, crucial idea. You will see what happens when a polynomial has the same solution 3 times. I will refresh your memory on this when we get there. Okay? So that's a polynomial equation, degree 5. It has to have 5 solutions. It happened that 3 of those were the same, and then 1 from here and -2 from here. X times x times x. Any questions? Okay. So you are responsible for these. Again, these are all review, and probably 5 of those we already covered in class. Okay? So moving on.
That is also due on Monday.
Yes, please. Please. So modeling with equations. On this section, I can talk for a month. So let's look at a couple of problems here in 1.6. Modeling with equations. What does this mean? Can anyone explain those 3 words? Modeling with equations.
Equation means S equals 0.
Right. But when I say modeling with equations, what does that mean? A real life situation then changes into what?
Equation.
That's it. In other words, a particular equation is applicable to a situation. That's what it means, modeling with equations. Fitting an equation on a particular real life situation. That's what it means. Very good. So let's start with problem 52. And that is on page 69. I'm going to copy the figure. Here it is. So we are given the distance between this person. I'm going to read the problem in a minute. Between the person and the tall tree. So we have the distance here. We have the distance of the shorter tree. And we have his height, which is 5 feet. Okay? So a woodcutter determines the height of a tall tree by first measuring its smaller one 120 feet away. Then moving so that his eyes are in the line of sight along the tops of the trees and measuring how far is standing from the small tree. So we have, this is the small tree right here, and this is the tall one, and we have this distance 25. We have this distance measured on the ground between the small tree and the tall tree. We have the height of this small one because he can measure that. And we have his height, which is 5 feet. Okay, so how tall is the taller tree? So here's our question. This is the question. I'm going to call this X. Better if we just call this X And this is 5 feet anywhere. That's his height, 5 feet. So he measured this distance. He measured this distance on the ground. He was able to determine accurately the height of the small tree as 20 feet. And now he's standing here, and his eyesight, so he's like an angle of elevation. So I stand here looking straight ahead, and the angle of elevation would be between this line, my eyesight till where I'm looking. For example, I'm looking now at the edge of the wall where the wall meets the ceiling. So this is the angle of elevation. So that's what he's doing. This is so he has, although he's trying to line up the top of the small tree with the top of the tall tree. So now, what do we look at? So what I'm looking at, I don't want to go over, so I have 30. Good. So I'm looking at one small triangle here. And I'm also looking at one big triangle. So if I remove them from there so we can analyze the situation better, then this is what I see. I see this height, which is 20 minus 5, which is 15. I see this x that I'm looking for. I see this distance, which is 125. And I see this distance, which is 25. But I also know that all this is 150. So again, I have these two triangles. I have this little one, the orange one, and the purple. Obviously, they are not equal or congruent, we say. They're not. One is tiny, one is big. But they have a lot in common, however. They do have this angle, which is common to both. So this angle is common to the orange triangle and also common to the purple triangle. Would you agree?
Yeah.
What else do they have in common? Both triangles are of what type?
Right.
Very good. So there is a right angle here and there is a right angle here. If these two angles are equal and this one is the same in both, what can you tell me about the other pair of angles? So what about this angle and this angle? For sure.
Wait, would they have to be the same too?
Right. Because if both angles are triangles are right and the two pairs are equal, right, or congruent angles, then the third pair has to be the same because they all add up to 180. So what do we know about two triangles that are not equal, congruent, but they have equal angles, pairs of angles? These two are the same, these two are the same, these two are the same. What do we say about those two triangles? How do we call the small triangle and the big triangle? They have a name because they have the same angles.
Similar.
Very good.
Really?
Yes. They are similar triangles because all pairs are the same, of angles are the same. Yes. So what? Okay, they're similar. Yes, they have the same angles. So what? Well, here's the trick, or I should say the deal, the big deal. Because they have the same angles, pairs of congruent angles, we can write proportions with their sides, but in a very specific order. We have to be very careful how we write the proportions. So I start with this angle. What is the opposite side of this angle in the small triangle? I'm still with the same angle. What is the opposite side of this specific angle in the big triangle? Good. I'm moving on now to this angle.
Why is it 15, not 20?
Because this is 20 and this is 5. So that must be 15. So that's why this is 5 and this is x. I move on to this angle. What is the opposite side of this angle in the small triangle? Notice that the small triangle must be at the top. Sides coming from the small triangle have to be at the top, because that's how I started. And sides coming from the big triangle have to be at the bottom. You cannot mix them up. You can reverse them. You can say I want the big triangle at the top and the small triangle. It doesn't matter. But all tops have to come from the same triangle, or bottoms have to come from the same triangle. So what does this equal to? The opposite of this angle in the small triangle. I go to the same triangle. What is the opposite side of this angle in the big triangle? I don't care for the last side. It will not give me anything anyway. What did I accomplish? Well, I do have something that I know is called, what is it called?
Proportion.
Very good. This is a proportion. I will cross multiply and I'm done. It's 225 with a 0. So it's easier for me to simplify. So I'll simplify by 5. And I'll simplify again by 5. So x equals 90 feet. But I have to add the 5 for the entire height. So x is 90, and I have to add 5. So total height, 95 feet. And we modeled this problem with an equation. It was a rational equation. We wrote the proportions with the sides of two similar triangles. We changed it into an equation. We modeled the real-life situation. We changed it or converted into an equation that was rational, a proportion. We cross-multiplied, and we determined the height of the tree. I have a few more minutes. I can do one more problem, and then we can stop. So let's say, yes, 41, dimensions of a garden. Page 68. A farmer has a rectangular garden plot surrounded by 200 feet of fence. So this is the rectangular plot. And what is 200 feet of fence? If it's surrounded by 200 feet of fence. Yes, of course. Thank you. Find the length and the width of the garden if its area is 2,400 square feet. So you have a lot of work for Monday. Okay, 1, 2, 3, the readiness quiz, the last problems, and install Maple at home. That's why we spend that half an hour or more in the lab. Okay? Good. So how do I start? What do I have to do immediately before I start the problem? I have to use how many variables? 2. I'm going to say x and y. Good. So then I will have to write a system of 2 equations. Can anyone give us a system of 2 equations?
X times y is 2,400.
Perfect. Excellent. And can anyone give us one more equation?
X plus y plus y, 2x.
Excellent. 2x. Let's do it. Very good. Excellent. That's perfect. Good. What do I do next? And how is it called? And by the way, I need the name of this. What is this? What does it represent?
Garden.
It's a system of 2 equations. They are not linear. This is linear, but this is a product of two variables. This is not linear. A system of two equations in how many variables? Non-linear system of two equations in two variables. How do I solve such a system?
Pick a variable to us.
Yes, pick a variable, but remember the two keywords. Never forget the two keywords. So what do you think I am going to do first? Which one? Yes. So
So it doesn't matter.
I cannot simplify this.
Oh. So,
How? Simplify. I simplify by 2, correct? No, I simplify because it's an equation. Because it's an equation, I can divide by 2. If it were an expression, I would have not been able to divide by 2. There would have been a factor in front. Good. So now from here, I'm going to solve for x. What will I do with this? Plug it in, the first one. So then 100 minus y times y equals 2400. Next step, please. What type of equation is it, and how do I solve it?
Substitution.
Yes. I solved this for x and I substituted. How do I solve this equation? Now what type is it?
This is quadratic.
Very good. Negative y squared plus 100y minus 2400 equals 0. I had to distribute. Negative y times y is negative y squared. Y times 100 and then minus 2400. What type of equation is it? Perfect. It's not simplified though. What do I have to do for sure? Multiply both sides by -1. I refuse to solve a quadratic equation with a negative leading coefficient. And yes, I will give it a shot at factoring. And you're right, if it takes more than a couple of minutes, then I will use the quadratic formula. So how do I factor that?
6 times 2.
Yes?
-16 and -4.
Very good. So there are two options then, y equals 60 feet or 40 feet. So that's not good enough. I have to determine x. So please tell me how much is x, and here it is. 100 minus 60 will be 40, and 100 minus 40 will be 60. Just want to take attendance, and then you are free to go. Sorry, I'm logged out.